Okay, so we are live now. So today we'll be starting to implement the keyboard buffer. So what this will do is right now that we have interrupts for keyboard. So the interrupt handler with interrupt number as 33 would be the keyboard interrupt, and this what this does is just prints it to the string. Instead of this, we want to buffer it into a string of say width 1024 length, so that we can input 1024 characters in one line at max, and then uh, use that input uh, in order to okay, I'll show you a sample. So what happens is if I type anything, right, it just logs it as uh, whatever I type directly onto uh, the screen without buffering into memory. So with that, what ends up happening is that we cannot. So you says you need to implement a shell. That's our next goal, right? To implement some kind of minimal shell uh, to start using the OS with its memory. So we want the whole string into a buffer to interact, to basically make some commands or something, right? So let's do that. So for that, what I have done here is create a keyboard buffer.h and buffer.c, and let us for a while think about its API. So I'm going to define hash and def keyboard buffer hash define, yeah, it ends with that, right? Right. So the API is gonna look something like this: void add to buffer, the okay. So S is that we're gonna just add in a character A, and what else? Flush buffer, no, yeah, void flush buffer. This will clear out the entire buffer, right? So that is that, and we need to initialize a buffer with some size, say, right? Int size of buffer fixed at say 1024 characters. So yeah, so that will be our API. So after we initialize our memory, so yesterday we found what was the issue with the address of these symbols, right? So my uh, reasoning was a little bit improper. So say you have a symbol initial page directory here, and we have defined it in the linker.ld. Linker.ld, if you see, we have defined the symbol here. And if you have a look at the built binaries obj dump, so obj dump, and I think T is the flag for checking the symbol table. OS build my OS.build. It says it's not done. Okay, hold on. So, yep. Uh, Heat start. So as we expected, it is at the address of C02 28. That's the virtual address that the linker will replace all of the references to this symbol. So how do we reference that symbol in C? So that is just by first adding the extern uint32 the symbol name, and use the address specifier, not like if you just say the initial page directory symbol, it will dereference that location and give you the content at that location. So we need the address. This gives you the address of the location. Okay, that was a concept clarification. So let us just implement this buffer. So what we have here is import keyboard buffer.h, right? Next, let's initialize the buffer. Net buffer int size will be void. Another thing I figured was that are we live? Yes, we are, right? Okay. See, so the another thing that we found was the VS Code seems to be pretty slow once we load some huge projects. So that's why I'll be just using VS Code for running the project, and then for editing we are gonna just use NeoVim, right? Let's open that. We are gonna go to keyboard buffer dot c. So what will be the init buffer? So let's define the symbol here. So this is going to be private to this file, so I'll not export this symbol. So char star buffer and hash include, we need to include the memory as well, slash memory dot h, and then so we need to allocate some memory for this buffer. So we'll just create a page. So that was alloca page, right? Buffer equals char star alloca page. The size will be the size. So let's just see its signature. Alloca page. Yeah, that size in bytes. It has to be unsigned int. It's a positive integer. Uint 32t. Edit memory dot h. So let's just change this to, yeah, that's exactly what we had done. Okay, sorry. Keyboard dot h dot h, right? So this is type, right? Yeah, so that's the size. That's all we need to do. So this allocates a 4 MB page because I think the buffer size, yeah, that is too much unless we do allocate a, yeah, we have to have a memory manager here, like a kmalloc kind of thing, right? This direct alloca pages is not good for memory management. We need a kalloca, which we will do it in coming streams. For now, let's just do this. Replace with kmalloc once the replace with kmalloc. That's all. Okay. The next was flush to buffer. Now in buffer is done. Add to buffer. So void add to buffer. Let's have a pointer to the buffer. Since this is again buffer index, and this will be 0. Right, add to buffer char c. So we need right now to print it out in this at the screen as well. So hash hash include stdio dot h, right? So add to buffer. What is that? So this will basically be what? So the let's just make this a struct. Right, we have to start using structs now. Right, so here we need to configure this. Yeah, if the buffer index is greater than equal to buffer size, we need some kind of a logger. Some kind of error logging, right? Don't do anything right now, just else. What we will do here is buffer in buffer. Okay. This just think about it for a moment. This is a buffer struct, and we have a buffer. Yep. Struct buffer struct. I hope that works. Right. So else what we will do is char buffer dot buffer of char buffer dot buffer index plus plus is equal to c, right? That's all. I think that should be enough. and we also need to print it out, right? Print mm, uh, printf. Okay, what were we doing in the keyboard thing again? This was an IDT, so we were just, yeah, yeah, right, right. So we have done that, we have done this, and we need a way to access this buffer, right? So do we copy the buffer or just return? Yeah, right now we'll just return the stuff. So first, let's just see if this works, right? Mm, we have the kernel over here. So yeah, edit kernel. So we were just allocating some pages. We don't need these samples now. We are comfortable with it, quite comfortable with that, right? So we have the page address, we have the new page address. You don't need this. You need the memory done. This one initializes the physical memory manager. Okay, now what we are going to do is allocate a buffer for buffering string inputs, right? So what this is gonna do is the init buffer of size 1024 and add to buffer and that's all. Hash include in that was buffer, right? Page. And do we need, yeah, we need that is fine. So that's that. Kernel is done, keyboard buffering is done. What's the issue? stdlib. Okay, so that is done. Yeah. Char buffer dot buffer of this. Okay. Okay. Yeah. Now we need to go to the IDT. IDT.c, right? Include the buffer. Keyboard buffer keyboard buffer.h, and whenever we see a keyboard input, instead of printing it key code scan code array, right, we're gonna do add to buffer scan code array of key code, right? I don't want to, if it is not released, okay, it is not released. If what is that? Released means released. If it is not released, then we print it out. That's how we are buffering. Okay, so this should do. Okay, let's look at it again. Initializes the buffer with size. Let's just add it sanity. Yeah, right. Let's try to run this. Okay, there are errors. Too many warnings. We need to address them. What's the issue? Isn't it? Have we not included the right file? Did include the keyboard, right? What? Yeah, right. We need to change the make file as well. So let us add the compilation of this is gonna be lfgcc. Yeah, let's do it like that. And while linking it, let's link that as well. Keyboard slash. Okay, what's the what? Why? Uh, right. What am I doing, dude? Size of unknown type name. Why? We need this. Okay, you are in a freestanding library. Remember, you don't assume things. Hmm. Okay, it's not buffering. Oh, what the hell? Um, that is adding. Hold on. So we get an interrupt. We call in this thing with the scan code, which is a constant character array. So you can see it right over here, right? And so we pass in the character, right? It comes on to here. Hmm. Add to buffer, char buffer, with buffer index. Oh, what the hell, dude? If, yeah, buffer index is 0. Okay, we need to debug this. GDB, and then shit. Okay, break at keyboard buffer.c, add to buffer. Okay, buffer size is 0. What the hell? Oh my god. Hmm. Simple, stupid ass mistakes. Okay, it does print. So, right when we press enter, right when we press enter, we need to um, clear the buffer, right? So let's check if the character C is /n, else if C is /n. Do something else. Hmm. Clear buffer. Flush. Flush. Hmm. Void flush buffer. What this will do? No, we need a way to the buffer contents, right? Yeah, that adds to buffer, that's fine. Hmm. Yep, we need a double buffer, I believe. So yeah, we're gonna get hmm, right. So mm, right, do this. Otherwise, yeah, we will just printf the entered uh, buffered. Or can I do %s? Have I added support for stdio? Percent? No, it's just /0 dx. Yeah, we haven't added for %s. So buffered, right? Printf. You can do it this way. Char buffer dot. Yeah, that is char star. That should work. Null terminated string. Hmm. Okay. So instead of doing this stupid thing here, what we will do is we'll check if it is greater than or equal to size -1. Hmm. Hmm. We need at least 2 slots. Hmm. Yeah. Uh, let it be that only. So if I go here and see, right, buffer, cat buffer, dot buffer, that should be null terminated string. So this will flush the buffer. This is going to print the buffer, and we are gonna clear the buffer. Char buffer dot buffer index 0. That's all we need. We can clear the buffer to zeros just to be safe. Should we do that? I don't think we need to. So when do we flush the buffer, or if we see /1? Right. Okay, but we need to still put it onto the screen. This one, regardless, we need to put it on screen, right? Don't care about uh, right. Yep, good enough. Say what? Why is it printing two lines, dude? Okay, the slash and mm, mm-hmm. It's gonna go and print. Yeah, we have to do this first. Just to get the okay. Now that we have a way to buffer stuff onto the screen. Now, the next step would be to this buffer is good enough. Now we need to implement a shell, right? We have to add a user space program and load it onto RAM. Once we load the kernel and thus initializing a RAM file system. So what we can do for that is think about it. Need to give it some thought. Kmalloc is a huge task, I believe. Like we need to basically handle the physical memory. I'm just thinking like there are too many ways this can go. Like, what utilities can you provide? Listing a file, creating a file. You need to have a program for each of them. And once you buffer, yep, just prompt a minimal shell, right? That's what this will do. Yeah, everything is in kernel space right now. Don't have a concept of user space is nothing but just having appropriate flags in the memory space, sorry, and switching to user mode when an application is launched. Yeah, we need to write our first user space program, but we need to expose these alloca pages or kmalloc. Basically this has the physical regions. We need to maintain a mapping between whenever you request for some memory, we'll just say that this region is mapped, and then the page fault handler will allocate so many pages. Just allocate a 4 KB page, 4 MB page. to that address. Once, so you first have to see if that address is within the mapped region, and then allocate the pages, right? Okay, we'll just add the API for that. So this will be void star, right? Void star malloc. Yeah, we need to, we can't, the identity is somewhere else. Maintain mapping of virtual addresses. Anytime malloc is requested, do the following. One is to one is to add this heap start, comma heap start plus size in bytes to the mapping. Local data structure within memory scope. 2, once you add it, any reference to the address would cause a page fault, in which case in the page fault handler, investigate the address. If it is mapped, only then alloc the pages, right? Yep. Freeing is a bit tricky. Right, we need this one as well as free. So Freeing is a bit. Hmm. Is this not public? Can I manage? Okay, let's do that later. Uh, hmm. Free, free address. This is a bit tricky. Let's start and heap and do the mapping. Add the information within the mapping in fixed size header to track the address. This is a simple linear memory manager, right? Not doing any fancy alloc stuff. Not tricky. This is not tricky. Investigate the fixed size header that has some unique flag to detect it. Then remove the mapping using the metadata from this address to the metadata cells. Okay, so that is freeing the address. But we need to also clear out the page, right? Oh. We can just zero out the pages, the region, but do not what do we say? Do not like change page bits, since we might use it in next allocation. Yeah, so these two are the priority things. Please implement the memory manager. Malloc free. Let's just have that. Yeah. It should be void. Okay. So that's fine. I think we'll do this. So we have done the buffer part. So before implementing the user space programs, let us just get the memory handling right. And a simple file system, right? we need to revisit the basics, get the file system going. Yes, that is about it. Thank you for today. We'll see you later for the CUDA stream where we implement SQL to CUDA translation. Thank you. Bye bye.